Okay. Okay. So, okay, sorry. Okay. So, thank you very much for Jamie make the invitation, the proposal to make this talk. So, like the name saying, I will talk mostly about foraminifera from the tropical Maastrichtian oceans. So I will present some kind of an history about this kind of foraminifera, mostly benthics, but I will talk a little bit more about the plantids also, and mostly about material from Colombia and some work we are conducting right now in tropical deep sea settings. So my talk we have this simple structure when I will give some introductory aspects, mostly talking about why it is important and why it is interesting the late Cretaceous in North and South America. Later, I will talk a little bit more about the foraminiferal assemblages and mostly the Maastrichtian foraminiferal assemblages from two formations, Colón and Mir formations. Both are located in Colombia and Venezuela apart. And at the end, I will maybe talk a little bit more on work we are conducting right now and some research perspective that we can do in Colombia and North and South America. So I think that I would like to begin this talk talking about probably one of the oldest reports from foraminifera in North and South America. I am not sure if this will be the oldest, this contribution from Herman Karsten in the 19th century, but I think it will be one of the oldest, at least with Cretaceous foraminifera. And one particular thing is that he reported probably one of the most common benthics and most I don't know, known benthics foraminifera for someone that are interested or are currently working with late Cretaceous in North and South America. Of course, at that time the name was Orthocerina, but right now we probably know it like Orthocarstenia. And one other aspect about this paper, about this contribution of Karsten, that he made probably the first geological map from North and South America, and he reported or described something that is really particular in North and South America. Is it was the presence of bit marine succession along all the Andean region, and mostly of this Cretaceous is related with marine conditions. So I think one of the most relevant aspects about the Cretaceous in general in North and South America is that it's an history related mostly with these widespread epicontinental seas. So we have this really extended marine conditions probably since the earliest Cretaceous until the end of the Cretaceous. And at least for the Albian to Campanian part, these kind of environments share, and I think that they share some kind of similarities with other localities when we have these widespread epicontinental seas, like, I don't know, Western Tidal Seas, the Northern Africa. So some authors used to use the name La Luna Sea to refer these epicontinental seas, at least from the Albian to the Campanian. Of course, and of course, this the formation of these epicontinental seas are obviously related with these major environmental changes that we have all along the late Cretaceous, mostly characterized, of course, by the end of these hyperthermal conditions along the Cenomanian, Turonian connection. And we have a transition, we already know that we have this transition and in the upper part of the Cretaceous, this transition between the Campanian and the Maastrichtian, when we probably have a little bit colder conditions, and we have also some changes in the global sea level condition. We had a retreatment on the global sea level fall, and we also have this volcanic activity reported in Deccan, in the Maastrichtian, and all along the KPG boundary. So the idea of this the talk is exploring a little bit more about the Campanian and the Maastrichtian transition, and how this time interval is present in North and South America. So I think the most relevant aspect when we talk about the late Cretaceous in North and South America is that in a little short amount of time, we have a really drastic change in the marine conditions, and this change is related mostly related with two causes. One of them, of course, this global sea level fall that we have at the end of the Cretaceous, and in the case of South America, the earliest stages of the Andean orogeny. That, of course, these two aspects are causing these major modifications in the marine conditions. So the interesting part is that the macrofossil and the microfossil content were able to record these changes when we have really open marine conditions with highly productive highly productive oceans at the Turonian and the Cenomanian and the Centonian, when we had also episodes of volcanic activity related with in this case, related with the formation of the Caribbean plate. And when we compare, for instance, with the record, the Campanian and the Maastrichtian, we have a shallower conditions with less productive oceans, but also with the formation of phosphatic layers. We don't have any or major evidence of volcanic layers, and of course the microfossils in general, foraminifera and other elements, were able to record this major or this gradual transition between the Turonian, Campanian, and the Maastrichtian. And one of the things, the aspect that we had to work a little bit more is how many of these changes are exclusively related with this tectonic activity from the Andean orogeny, and one of these changes are related with major paleoceanographic events that they are already reported in other locations. In some cases, we had these two processes interacting at the same time. So this is the kind of question that we need to explore with, not also with foraminifera, but with many with any process we have. So when we concentrated we make a kind of zoom in the area. Colombia, in this case, Colombia and Venezuela. There are some reports that when they recorded this transition in between the middle shelf to coastal continental conditions between the Campanian, the Maastrichtian, and the early Paleogene. There are several lithological units when we had the chance or the possibility to track this change. And I will talk a little bit more about two areas, mostly this one with the black square related with a unit called Colon Formation that in both cases, at least for the late Campanian and the Maastrichtian, is related or was related with exclusively marine conditions. And with the red star, I will talk a little bit more about the Umir Formation, that is a unit that is a kind of transition between marine and exclusively continental conditions. So one of the advantages that we have in general in Colombia, Venezuela, Ecuador, northern Peru, is that we had the chance to track these environmental change all along the Campanian and the Maastrichtian, because we have a kind of extended geographic sedimentary succession. So we had the chance to track, to correlate several localities with this age. And of course, for making this correlation, we use several authors that use a lot of paleontological, mostly proteins. So yeah, of course, we have the ammonites, the inoceramides, etc. We had also the palynological record represented by pollen spores, dinoflagellates, a really useful tool in protein in this area. Calcareous nanofossil, we had a few reports so far, but of course we had calcareous nanofossil in these successions. And I will talk about the foraminifer that is a traditional tool used in these localities. So in order to give a little bit more context, I will talk about this particular unit, column formation, that is located in, like I say, in the Blood Square in northern Colombia. And when the researchers work with foraminifers in the Cretaceous in northern South America, probably will read this classic paper from Cushman and Herbert. This is the 41, but they have another earlier paper in the 1930s. And this is a really classic paper because they propose 3 regional assemblage zones that is Paulownia cretaceae, Siphogenenoides branleti, and Ammoaculitis colombiana. And despite that, we can have some problems using only exclusively benthic foraminiferal assemblages. They proved to be kind of useful to make this kind of biostratigraphic schemes at the beginning of the 50s. So another aspect about this classic paper is that they were the first, it was the first report that talk about a little bit more about the diversity of the forest that we had invented and planted assemblages, mostly related with the lower and middle part of the column formation. Another classic paper, and this is a paper in Venezuela, but it's really close to the paper of Cushman and Herbert, and it's mostly based in the lower part of the column formation, the Socuy member. They report the same kind of assemblages, but at that time, Cellier de Cipoua worked a little bit more about the planted foraminifera. And one particular aspect that point out both Cellier de Cipoua, Cushman and Herbert is that most of the benthic and planted forest that we have in column formation and Maastrichtian in general in Colombia, they share many similarities with the Maastrichtian and the Campanian benthic foraminifera and planted from the Western Interior Sea. So yeah, we have a kind of idea, and usually when we work with this kind of foraminiferal assemblages, it's kind of common to use reports in the Western Interior Sea, like Fritzel, this kind of papers. Many years passed, and until the 80s, there was another paper, kind of polemic paper in the between, that it was the paper of Gandolfi, that we probably know. But I will refer this paper of Martinez in the 1899, because what did Martinez? He revisited a locality from the column formation that actually worked Gandolfi, and he used the planted foraminifera assemblages, the planted foraminifera zonations, in order to calibrate these assemblages zone that Cushman and Herbert proposed in the 40s. So they proposed, Martinez proposed, that Paulownia cretaceae, Sipho are indeed Maastrichtian foraminiferal assemblages and related with the Plotruncana, Agitiaca to Abatonphalus majarensis interval. So we have kind of latest Campanian some way to middle Maastrichtian interval for these zones. So this is a really relevant paper, and he also report many of the usual four benthic plants that we have in the Colón Formation. So with this kind of introduction, I will talk a little bit more about the study area, pointing out that this is the Cesar Rancheria Basin. Is a basin that is located in between Colombia and Venezuela mostly. And I would talk about this locality that is Diablito 1. Diablito 1 is a core that was collected by the Drummond Coal Company. It's a really famous locality. Probably you probably heard about the Titanoboa, but in the case it's related with the Paleocene. But in this area, they collected a series of cores, and that I indicated in the map. I don't know, I will use the pointer. I need a pointer. Okay, so in this map, we have this area. The number 3 is the locality, the classic locality of Molino section. That is the locality that use Martinez for calibrate the zones of Cushman and Herbert. And the red star is Diablito. And Diablito, the idea was to try to analyze all the Colón formation. It was the original idea with Diablito. However, when we analyze the material that we have in Diablito, we conclude that we were dealing with a part of the Colón formation, not all the Colón formation, but only a part. And it was possible to recognize using the foraminiferal assemblies when we were able to recognize not all the 3 zones of Cushman and Herbert, but only the second one, Cifobralete, and the upper one that is Amoaculitis colombiana. And we took advantage also that we already know that we had the KPG boundary recognized in the same core, this case for the La Parra, that they were able also to recognize the iridium anomaly. So we had a kind of a pretty clear an idea that we were dealing with, in this case, with late Maastrichtian strata. Probably we made some kind of estimation on the sedimentation rate. We were probably dealing with the last 1 million years before the KPG boundary. And in this case, this sample is the lower record that we were able to collect in this course. So that's why I don't have many. We weren't able to have all this foraminifera in this sample. In general, the benthic the foraminiferal assemblages in Diablito are dominated by benthics. We were able, of course, to recognize the 2 markers, Cifobralete and Amoaculitis colombiana. That's kind of old Amoaculitis. But in general, the preservation it was not so good. It was kind of moderate in most of the samples. I had to say that. With the plantids, they were mostly dominated by Wembelitra Cretaceous. So this kind of information, they are telling us about the particular paleoenvironmental condition of this area. So yeah, we also collected information with geochemistry, with use another approaches like ostracods and calcareous nanofossils, but I will only discuss the foraminiferal data in this talk. So in general, when we explore, for instance, the proportion of the foraminiferas as a whole compared with the ostracods, we notice that the ostracods are mostly related with the upper part of the Diablito core. When, for instance, we compare basic relations like the proportion of calcareous in comparison with the agglutinate, we notice that the agglutinate are more common in the upper part of the section. And for instance, when we explore the proportion of the plantids, and like I say, they belong almost exclusively with Wembelytra Cretaceous, we notice that the plantids as a whole are present in the lower part in the section, and occurs in the calcareous nanofossil share. It has a really similar picture with the plant foraminifer. So in general, when we explore this data in Diablito, we notice that we have two intervals. Interval probably related with deeper conditions and deeper with quotation marks, and a really shallow conditions in the upper part of the record. And when we explore this kind of data with geochemical data, and I won't talk too much about this data, it's only to point out that with geochemical data, when we explore the input of the regional material, some kind of estimation of paleosalinity and paleowatering intensity, we notice also that we can segregate the Diablito core in two intervals. So in general, we can conclude, at least with the data that we have with benthics, plantids, calcareous nanofossil, ostracods, geochemical data, that the late Maastrichtian interval, that means the lower part of the Diablito core, we're probably related with an environment, maybe from an inner shell with some kind of diazotic condition and oxy conditions. In comparison or in contrast with the upper interval, when we have shallower, really shallower conditions. And something that it was interesting is that this shallower condition, this prograding system, probably is related with these stages that the Andean orogeny that I was talking about a little bit earlier. So by sure, the progradation that we have in this area are exclusively or mostly related with tectonics. We have to explore a little bit more what is the role that these global sea level changes that they are reported for the Maastrichtian can be related with this kind of strata. But I think, or my guess is that in this area we will be recording mostly tectonic origin inside nice. So just to maybe to give a complete idea that we cannot data we can find in the column formation, let me show some images about the lower part of the column formation, the kind of fauna that was confrontedly expected in Diablito, but we weren't able. But it doesn't mean that in this area we can collect this kind of data. And this, for instance, belongs to another core in the same area. These are unpublished data, but it's only to show you the kind of preservation, the kind of diversity that we already have, in the column formation in the lower part, that they are clearly indicating a normal marine condition and probably deeper conditions, or probably no, there are deeper conditions. There were deeper conditions in the column formation. So it's just to give to all of you an idea of what kind of environmental change we have in the column formation, and how the foraminiferal assemblages were able to record this environmental shift. An additional aspect that I would like to introduce, really brief, is the case that what happened between the transition between these La Luna Sea conditions that I was talking about a little bit earlier. What happened in this transition with this open marine condition that we are able to record in the column formation. And something that is interesting is that several authors using geological data, geochemical data, in paleontological data, many authors propose a really deep contrast between La Luna and the underlying formation that we have in the areas. And for instance, this was kind kind of small paper that we conducted in another area in Colombia, but using geochemical data, foraminiferal data, lithological data, yeah, we were able to record this contrast, and some authors propose the probably present kind of regional discordance or some kind of xenoconformity. And yeah, in general, the idea with the thing that we need to explore a little bit more with this contact between at the end of the La Luna Sea and what were happening in the column formation is this kind of environmental and lithological change is exclusively related with tectonic activity, or we can also have some kind of paleoclimatic or major paleoceanographic changes. Right now, yeah, this is the kind of idea we need to explore a little bit more. So in order to maybe to explore a little bit more about this change, we visited a locality located in the central part of Colombia, in this case related with Umir Formation. But again, we have this contrast between lithological units related with the La Luna Sea, with this open marine condition, highly productive, with a shallower unit, in this case with Umir Formation. We explore the content of the foraminifers and the ostracods and geochemistry, the same approach with with Diablito. And we were able to record a kind of mix between something that we have in Diablito and something that we weren't able to record in Diablito, but also reported in the column formation. We were able to, I don't know, to track or to have a little assemblage, foraminiferal assemblages related, at least for some part of the section. I will move a little bit more. With some part of the section are related, at least this part, this lower part, related with middle shelf conditions, and the upper part is really similar to the kind of foraminiferal assemblages that we have in Diablito. So something that was interesting is that in this case, in Agua Blanca section, we have only 20 meters. And in these 20 meters, we found more or less the same change that we explored in Diablito. And in Diablito, we were talking about 200 meters. So we had, with this idea in mind, we had I don't know, we know that the sedimentation rates, of course, change all along the North and South America, and again, probably related with these early stages of the Andean orogeny. And something that is interesting, or was interesting in this locality, is that with the foraminifers, with the nannofossils and the geochemistry, we were also able to recognize this contrast that we had between these La Luna Sea-like units in comparison with when this part of the lower part of the beginning of the Maastrichtian. So again, we have this contrast, and you probably any that is interested in working this kind of material in Colombia, they will probably have this kind of contrast all along the Andes in Colombia and Venezuela. So it's just that maybe the timing of this contrast will change, and this is an additional challenge that we need to work a little bit more. So in general, I was talking about something that is kind of local or regional, that is the Andean orogeny, but it doesn't mean that the tropics had the potential to record these major environmental changes that many authors report in all along the Campanian-Maastrichtian and all along the Maastrichtian, and of course the KPG boundary. So in order to have an idea of what was happening, we need to start to compare with with reports in another areas. And this is a really recent report from the Banco Ponelli and Belikov, when they revisited these localities in the Maastrichtian type localities, working with foraminifers. Some of them we share some similarities, some of these four that they report, But the idea, or this is the idea with the final part of of my PhD research, is try to figure out what was happening with the deep sea tropical settings. So that's why we had material from Demerara rice that is really famous, and also from Nicaraguan rice. With Nicaraguan, well, we had some kind of preservation problems. So far we already had only geochemical data. But the idea with Demerara is analyze this interval that is comprising the Campanian and more or less all the Maastrichtian. And the idea is to explore how was their response in this case of the benthics, so far of the benthics, and also conducting a geochemical data. So far, I am let me see. I need to work a little bit more on the samples. I need to work, 20 samples more, but we already had geochemical data, and in this case, elemental radius. And the interesting aspect is that with this kind of basic geochemical exploration, we were already able to recognize some kind of change at the beginning of the Maastrichtian in comparison with the upper part of the Maastrichtian. And something that is interesting in this part of the tropical Atlantic is that there are other reports, for instance, based in neodymium isotopes, that they were already talking about some kind of reorganization in the mass waters, at least in the tropical Pacific. So my hypothesis, and I think that at least with the foraminiferal assemblages that I am working right now in the Merara, is that the foraminifera will be able to recognize at least some kind of general shift between the lower part of the Maastrichtian in comparison with the Maastrichtian. So this work that we are conducting right now, but yeah, I think that we will be able to present in the near future, maybe in forums, I don't know, some kind of interesting data about this tropical deep sea foraminifera in general, the kind of foraminiferal assemblages that I am finding in the Merara are typical deep sea assemblages with I don't know, we have mostly dominated by calcareous forms. We had some interval when we had a little bit more agglutinated, but yeah, in general, it's the same, or it's the kind of the deep sea foraminiferal assembly that usually expect in this kind of record. Yeah, that's the idea with with the Merara. Try to complement all this info that we had already in shallower conditions in the tropical in the tropics, and try to compare with the deep sea, and in this case. So for anyone that maybe will be in the Cretaceous Symposium, we can discuss a little bit more about these results in Diablito. I will talk a little bit more, of course, about the obstacles and the calcareous nanofossil there. And yeah, and I would like to thank to Drummond that they collected the material, to Smithsonian, because they actually store the material in Panama right now. Of course, to IODP for providing the samples from the Merara and Nicaraguan rice. Unicinos, a place where I'm doing my PhD, and of course, Ecopetrol for giving me the idea of forgive me the idea to work with this material when I started to explore this material, I don't know, 10 years ago. I think that at that moment, if we began this idea of working a little bit more with the Maastrichtian foraminiferal assemblages from Colombia. So I think this is all. So thank you very much. And I don't know if you have any questions about this talk.
Well, thank you, Herman, for your presentation. Now we can go through questions. If any of you have any question, you can type it down, or you can open your microphone and ask German directly. Don't be shy. And in the meantime, those are really nice forums. The ones you presented from the column, they are very well preserved.
Yeah. I think that when I was, I don't know, deciding which material we would like to work, I would like to work in Colombia. I had this idea clear that no, if I need to work with Maastricht. I really like, I don't know, the Elvian, Sinomanian. There are really interesting stages to work, but I know that the preservation issues are kind of complicated sometimes. So yeah, because I already knew that the Campanian and the Maastrichtian have more potential to find really interesting assemblages. That's why I don't know, I decided to work with this kind of material. I didn't have so much luck maybe with the Diablito, but despite of that, I think that we were able to collect really interesting data in Diablito, and mostly because, or mainly because, yeah, it's kind of interesting to try to relate this basic paleoenvironmental data that we had with foraminifers and try to correlate with these major tectonic events that were occurring at that moment in the Andean region. So, yeah. Any questions? Brian.
Yeah, nice presentation, and I agree. Beautiful forams from the clone formation. I might have missed it, but the cause of the deepening in the clone formation, is that tectonic and because of increased subduction rate at the plate boundary, or what is the cause?
No, I think that some authors already are proposing that maybe I can move. No, okay. Some authors propose that all along the La Luna Sea, or in general La Luna, the Campanian, the Turonian, the Santonian, we already have open marine conditions in Northern South America. It's just that probably related with the earlier stages of the Andean orogeny, there was some kind of change in the kind of the positional environments. We passed to, I don't know, to sediments mostly dominated by pelagic and upper marine sedimentation, to something that it was kind of myths in the source related with this siliciclastic material. But at least in this part of the lower part of the column formation, I think that we continue having these kind of upper marine conditions. It's just that there was some kind of shift or change in the, I don't know, the supply or say or the detritus in the area. But yeah, I think that at least for the lower part of the column formation, we already had, or we continue having open marine conditions.
Thank you.
Oh, Brent Wilson. Brent, would you like to open your mic and make your question? Okay, so I will read it. A lovely talk. Okay. Brent says, according to the Shipboard Scientific Party, at least part of the companion part of ODP hole 1258A contains many radial ions. with very few planktonic foraminifera. This decrease in abundance near near the Campanian-Maastrichtian boundary. Can you comment on the cause of the high radiolarian abundance?
I think I don't have an answer for that, but what can I say? What I can say about the late Campanian, at least in the site, is that at least the two lower cores that I am working, that is, I think, is the 34 and 33, that they comprise the Campanian-Maastrichtian. They are kind of different in comparison from the 32 and 31, and that is the part when I in the graphic I point out that we have that kind of change in the concentration, for instance, in the silicium and the firm. So honestly, I'm not sure. I need to explore a little bit more the data, but by sure, I think that it's related with this change that some other authors are proposing for the tropical Atlantic Ocean. I don't remember the name of this paper, but it was mostly based with neodymium data. I think this work have data from Northern Africa. I'm not sure if the North Atlantic, but he or she, I don't remember, made some comments about this change that, at least with neodymium, probably have along the Campanian and mostly the Maastrichtian. So yeah, I think it could be related with some kind of environmental change, but so far I am not able to make some comments, additional comments about that. Sorry.
Okay, well, and about to comment, Catherine, she texted, thanks German, interesting, and claps. And time for, oh, Brent says, thank you for the answer. And I think if there are no more questions, maybe we can close the session. We will send the link for all of you who synced to the forum, and yes, there are no more. So thank you, Herman, for accepting to give the talk. And oh, Alexandra, there's a last comment. Alexandra, would you like to open your mic and ask? Or maybe, German, can you give us your email by chat so people can address you with further...
Yeah. It's not kind of regional question, but yeah, it's interesting. I think there is a lot of evidence about this conformity. So, okay. Jamie, I think there is another question.
Yes, Bamerni, wanna open your microphone?
Hello, everyone. German, thank you very much for your interesting presentation. Your job is appreciated. I wonder if my voice is clear. Okay. I worked on like nearly not same project, but I had worked through my PhD on the transition between Cretaceous-Paleogene in Iraq, Tethys realum, and my deposits were also azimures, were pelagic, full of planktonic foraminifera. was interested in biostratigraphy, but in somewhere near the middle Maastrichtian, I saw in 4 locations, like more than 4 kilometers between each and another's, there were a barren zone. That zone, like for more than 15 meters, it was really empty of any planktonic, benthonic, foraminifera, ostracoda, or even radiolaria. Did you, like, by accident, have the same condition in your study? Or you can, like, advise me what to focus on regarding this barren zone? Thank you.
I think that I didn't understand completely the
Okay,
question.
sorry.
So I don't know if you maybe can send me an email, and maybe I will be able to ask the question.
Yeah, thank you. Yeah, I will do it.
Well,
Thank you.
German, can you type down your email on the chat so people can
sure.
contact you?
Yeah.
And then we can.
Yeah.
So there you have it. So Alexandra and Abdul Rahman and other people who are here, if you want to contact German, there you have German's email. And well, so thank you very much for participating, and we will see you on our next seminar, September. It's going to be about evolution of Cenozoic planktonic foraminifera, and we will send you further information as soon as we have it. Thank you very much, and see you later.
Okay.
Bye.
Thank you. Bye-bye.
See you. Bye-bye.